Now, today we are talking about electrical power. What is the electrical power and what is the formula that we have to use it to find electrical power? The electrical power is the rate at which electrical energy is converted into another form, such as mechanical energy, heat, or light. So the electrical power is a rate which the electrical energy. Now, all of us know, like the hair dryer as an example. We have for the hair dryer, the input is an electrical energy, but the output is a heat. Another example, the lamp. The input is an electrical energy and the output is a light. So the rate to convert an electrical energy to a heat or light or a mechanical energy, the rate of this changing is, we called it electrical power. How to find the electrical power is by a product of a current times a voltage. So if you multiply the amount of current times the amount of voltage, you will find the electrical power. So the power, so we will say now that the power here is IV. This is the power. I times V. I times V. We said before that the resistance R, it could be V over I, or the I times R is V, or V over R is I. These are the formulas, or those are the formulas for the resistance. So V over I is the resistance, but I times V is the power. So then, we know that the unit of the voltage before, it is a volt, and the unit of the current is an ampere. So how would be the unit of the power? We said that the power here, let's change the color first. The power, we said before that the power is V times I. So V is a volt. The unit of the I is an ampere. So the volt times ampere, or the unit of the power, we called it watts. So the unit of the power is watt. Where's the watt? Is 1 ampere times 1 volt. Now, the power and the voltage on the light bulb read as 60 watt, 112. Look at the bulb here, the lamp, sorry, on the circle here. You found 60 W and 120 V and white. This white, that means the color of the lamp is white. So 60 W, it means that the power of this lamp is 60 watt and her voltage is 120 volt. So we read that as 60 watt, 120 volt. Now, if you know that the power is 60 watt and 120 will be the voltage, so how can I find the current? We know that the power is I times V. The power is given, it is 60. I is unknown, V is 120. So by dividing, you will find the current is 0.5 ampere. So the current that is passing through this light bulb, it will be 0.5 ampere. This is how to find the power. Is it clear?
Yes.
Yes, teacher.
So when we say that a lamp rated at 120 watt, operated on 120 volt line, That means if you go view that the power is 120 watt and the voltage is 120 volts. So what is the current? As we said before, the power is I times V. So 120 equals I times 120. So you will find that the current here is 1 ampere. So a lamp that is rated at 120 watt on 120 volt will give you a current of 1 ampere, as we see here when we evaluate on the formula. Now there's another, or not another, like an extension of the unit watt. We call it kilowatt. Kilowatt, it's mean 1000 watts. And kilowatt per hour represent the amount of energy consumed in 1 hour at the rate of kilowatt. So sometimes if I told you we have 5 kW, 5 kilowatt, that's mean 5000 watts. So as we said before, the power is a current times the voltage. So the P, we write it as P equals I times V. The unit for the power is watt. The unit for the current is ampere, and the unit for the voltage is volt. So the SI unit for the power, as I told you, it is watt. Now, if we compare, now, as I told you before that the resistance is V over I. So because of that, I times R is V, and I is V over R. Now, don't forget these two formulas here, that V is I times R, and I is V over R. Now, and we said also that the power is I times V. So if I give you the current and the voltage, you can find the power. And if you substitute here with I, like it is V over R. Here, I, it is V over R. This V over R times V. So we have, we differentiate, we find a new formula to find the power. We can say that it is V squared over R. So there's another, now we have another formula to have the power. If you find, or if you have the resistance, if you have the voltage, you want to find the power, you will say that it is V squared over R. So the other formula here, that is P is V squared over R. And also, if you write it now as R as P is V times I. Now, instead of writing V, I want you to write I times R. So I times R times I. What did you have now? I squared R. This is another formula also to find the power. So the third formula here is P equal I squared R. Is it clear? How can I bring these three formulas?
Yes, teacher. Yes, teacher.
So the three formulas to find the power, first, I squared times R. If I have the current, I have that times the resistance, I need to find the power. I say it is I squared times R. If I have the voltage and if I have the resistance, I will say that V squared over R equals the power. And if you have the current and the voltage, I will use the main formula, which is I times V. Let's have another example here. When a hair dryer is plugged into a 120 volt outlet, so at your home, as you imagine that we are now in America, your voltage, the current that's come to your home is 120 volts. So you plug the hair dryer in a 120 volt. So as I told you now, the hair dryer here, we have like a machine. The input here is an electrical energy, sorry. And here we have a power, which is the output. This output power, it comes like heat, because we know that the hair dryer gives me a heat. So the electrical energy here, the current, the voltage, that is when you put the plug of the hair dryer on the home outlet, you give me the voltage 120 volts, and the current is 9.1 ampere. So at your home, the current is 9.1 ampere, the voltage is 120 volts. I want now to find the power. So what did we say? We say that the power is I times V. Whereas I is 9.1, the voltage is 120. Let's multiply them here now. You will find that the power is 1092 watts. Now let's write it. I want now the answer as kilowatts. What you have to do, you have to divide by 1000. So you will get it as 1.092 kilowatt. This is the power that is the power rating of the hair dryer. Is it clear?
Yes, teacher.
Yes, teacher.
Do you have any question?
No, teacher.